To measure insulin and glucose response, we do a very specific set of tests. Normally what we do is we give somebody a sugar load, normally with a lot of glucose, and then we see what happens to their blood concentrations of insulin and glucose after that meal. So normally we look at this time, maybe a 2 to 3 hour time frame after the meal to see what happens. So if we look at a graph of these concentrations, what will happen is we have our meal at this mark right here. So what happens is the curve will look something like this. In that, what happens is the glucose levels rise. And as the glucose levels rise, our body says, wow, we have a lot of glucose in our blood. Let's get that into the cell. And as it says that, it starts releasing insulin. So the insulin levels follow the glucose levels up. And as the insulin levels get higher, they pull the glucose into the cell, and then we have a feedback loop that pulls everything back down to normal resting concentrations. Keep in mind that this graph is not to scale because I have no actual concentration gradients on here, and we're skipping some values below. But the general gist of the insulin and glucose response to a sugar load is that glucose rises, then insulin rises, and as insulin rises, the glucose comes down, and then your insulin goes down. Now that we know how a healthy individual responds to a sugar load, we can look at what happens with diabetics. You've probably heard of diabetes. You may even have diabetes. But we classify diabetics in two categories: type 1, or insulin-dependent diabetics, and type 2, or non-insulin-dependent diabetics. So in type 1 diabetes, what happens is you don't produce insulin at all. There's nothing. Normally it's from an autoimmune problem that causes you to destroy those beta cells in your pancreas so that you don't actually produce your insulin. So let's see what would happen to this curve as we eat a sugar load at the same spot, but we don't produce any insulin. Well, our insulin levels, as we know, are flat. They're flat, zero, basically zero. Now, we eat our meal, we have flat sugar load, and then our glucose goes up. But what happens? Well, it stays up. It just stays high because there's no insulin to pull it back down. So what happens is over time it will eventually go down, but it stays very high. And the issue with this is that high blood sugar, especially sustained elevated blood sugar, can be really detrimental to your health. We'll go over that in a different video or maybe a reading. But you have to take my word for it right now that sustained high blood sugar levels are not healthy. So type 1 diabetics can be very unhealthy. What we do to treat type 1 diabetes is that we give somebody insulin. They actually give themselves a shot of insulin so that they get a peak right here, and that will help pull their blood glucose levels back down to the normal range. In type 2 diabetes, there's not a problem with insulin production, but a problem with insulin sensitivity. Recall that when insulin, this blue hexamer, binds to a receptor, it signals a protein to go and allow glucose to enter the cell. In type 2 diabetes, there's a problem right here. That's insulin sensitivity. This insulin is not having the effect that it should be having. Now, if it's actually with the signal transduction pathway or with something else in the pathway, I'm not going to get into, but at this point, there's a problem with the signaling of insulin to get the glucose into the cell. So what happens here is our glucose levels start to rise and insulin levels start to rise. They follow. But as glucose continues to rise, our insulin follows just like it did in the first one, but it doesn't have the same effect. It just doesn't pull the glucose back into the cell like it should. And so what happens is you get higher glucose than you should. And eventually, it does pull it back in. Say we have something like that, maybe the insulin would stop earlier. But it does pull the glucose back in. But in the middle of this curve, you have very high glucose levels, which, as we recall, is not very healthy. So the problem is this is a forward feedback loop. As you are less insulin sensitive, you produce more insulin, and that often causes you to be less insulin sensitive again, and you get worse and worse as a type 2 diabetic. until eventually what can happen is you have problems with the beta cell in your pancreas trying to produce too much insulin at the same time, and you can actually start to become type 1 diabetic, which means that you're not producing the right amount of insulin. In fact, you're not even producing insulin at all to help bring these glucose levels back down, leading to sustained high levels of blood glucose, which is incredibly unhealthy.